All right, so welcome to Wednesday, April 27th, the last day of... actually, it's not the last day. There's one more worksheet I want to do. I'll probably give it Monday, Tuesday. It's in class. It's just a review of all the calculator buttons to make sure you're good with that. But today's the last calculus-specific day. And so that's, I don't know, it's kind of like mixed emotions here. It's great. On the other hand, we're almost done. So let's get out the packet for this week. Today is multiple choice topic 6 and free response topic 1. And I don't know why I don't make these line up, because they're both over area and volume. So I should go rename them, but that would take too much effort on my part. Instead, I spend all my effort trying to match up which topic goes with which topic. Whatever. Today is area and volume focus. This was the last thing we did before we started reviewing, so it's the last thing we'll do as the review. I will remind you that on Monday, May 2nd, this worksheet packet is due. And Sunday, May 1, video, actually not videos, but video 6, and the algebra review and Schoology is due. I'm starting to see some of the algebra reviews get done. It also shows me how long it took. I think the longest I've seen was like 23 minutes, and that kid got them all right the first time, so he didn't have to do a second attempt. Most of them are like 10 to 15 minutes on the first attempt, and then like 5 minutes on the second attempt when they go back, figure out what they messed up, and fix it, and make 100. So all told, 20-25 minutes for the algebra review. The video, I assume, is about an hour, so don't forget to do those things. Easy 100s, but you got to do them. And then this packet, we'll go over the last part today, and then you'll have the rest of today and Friday to work on it, and maybe finish it by the weekend. All right, I need to, oh good, there's room on the back. So flip it all the way to the back, blank page. We'll just do like 4 or 5 lines of area volume review here. So just a couple things to remind you. The area you can get from the integral. Hopefully you know that by now. The antiderivative, so you underive, also tells you the area, and kind of depends on the problem which way you want to do that. From a to b, the top function minus the bottom function, dx. So that area right there, the integral from a to b, top function minus bottom function, dx. Sometimes the bottom function is 0, like this is the little more, I don't know, usual case, I guess. If you want the area to down to the y-axis, and that would just be integral from a to b of f of x dx. Okay, like this is pretty straightforward. We've done enough of area to remember that this is how area works. Volume's a little trickier because there's several different ways to do volume. The first way we did was by cross sections. I guess let's take that same graph we just drew, and maybe there are cross-sectional triangles coming up out of the page. So that volume would be the integral from a to b of all the areas. You're just adding up the areas. Well, you say areas. Maybe it's better to say you're adding up the volumes, because area times dx, the little bitty thickness, gives you the volume of each slice. So you're adding up the volumes from A to B. And so that's the one where, do you remember the equilateral triangle volume? Or equilateral triangle area, I should say? Over 4. S squared. For an equilateral triangle. The rest were pretty easy. You know what a square is, you know what a semicircle is. So the rest weren't too bad. Then we did volumes by disks. Let's see, so from A to B, this is if we rotate something, pi times big R squared dx. I guess the main two types are cross sections versus volumes of revolution, where you create the volume by rotating the shape around some axis. And then the last type was washers. And what was different about washers? What's the formula for washers? Big R squared minus little r squared. And after looking through this packet and the test that we took, apparently this is a common, it's not big R minus little r squared. Don't do that. It's big R squared minus little r squared. Because it comes from outside circle minus the inside circle. That's where that comes from. So hopefully this is not an option for you, because that's not big circle minus little circle. All right, with that as the 7-minute review of area and volume, let's do a few of these together. We'll start with the multiple choice and kind of build up to the free response. Unless otherwise indicated, set up the integral expression and use a calculator only to integrate. Do not use the calculator to graph. Do that by hand. So a lot of these are no calculator, so you've got to be able to graph them by hand. So first one, find the area whose region is bounded by the curve y equals x squared, y equals 0, x equals negative 1, and x equals 2. I feel like that's a pretty good starting point, because I think we all know what y equals x squared looks like. Parabola. Negative 1 to 2, down to the x-axis. There's my picture. X squared, y equals 0. So the area then is the integral from negative 1 to 2 of, if we always want to think top function minus bottom function, we can. So top function is x squared minus, what's the bottom function? 0. So don't really have to worry about that, but that way it sort of fits everything if you want to put the 0 in there. So that would be x cubed over 3 from negative 1 to 2. So 8/3 minus negative 1/3. Ooh, careful. Now I see where 7/3 comes from, but that's not the answer. 8/3 plus 1/3 would be 9/3. Feels like on multiple choice, like some of the wrong answers are algebra type mistakes and others are calculus type mistakes. I don't know where the 11/3 and 5 would come from. Oh, I know. Well, I think you get 5 if you just did 2 squared the 2 squared minus 1 squared would give you 4. So I don't know. I don't know where the 5 comes from. Let's skip down to 103. Because a lot of times, especially on the no calculator part, to spare you the time of actually integrating, like there'll be times they test that, but if they specifically want to test how to set one up, they'll give you your answer in terms of integrals, so you don't have to do the calculations, but you do have to know how to set it up. So the area bounded by this parabola and this line. So no calculator means I need to be able to graph these so I know which one's on top. Let's see, 2 minus x squared. So that would be starting at 2 and a downward parabola. If you need to just plain out plot points, there's nothing wrong with that either. Okay, so there's the parabola from -2 to 2. I hope that's enough. We'll see. Oh, I'm not sure. Some of the limits have 3 on them, so let's be careful. Y equals x minus 4. So we'll go down to -4 and go up 1 over 1. So they do intersect at 2. But I need to figure out where they intersect on the other side. Looking at my choices, where do you think they intersect on the other side? Based on your answer choices. Like, I assume -3 because that's the only one that would make sense. I need my upper limit is 2. That's the only one that has an upper limit of 2. I don't know what's going on here in part D. Yeah, I don't know what that's about. I'm thinking the answer is C. Let's see. Another way to make sure or to see where they intersect would be to actually just set them equal to each other. Maybe should have done that from the beginning. So x squared plus x minus 6, x plus 3 and x minus 2. So yeah, they intersect at -3 and 2. So the top one is 2 minus x squared, and the bottom one is x minus 4. Careful with the minus signs.
So once we found that this is there, wouldn't it not matter because they're the only ones that have...
I think so. I think once you found this, and you know that you're integrating from there to there, that's the only option. It's got to be C. So I would circle C and move on. If you wanted to verify it later, maybe you put a star next to it and think, I'll come back and finish that problem and make sure. But it's got to be C. I'm almost there verifying, so let's look. -x squared, a minus x, and a plus 6. So yeah, it's C. But yeah, as soon as you get those points of intersection, it's got to be C. There's no other options for it. 104 is a little bit harder because how in the world am I supposed to graph that thing? Y squared equals x times 1 minus x. I think without a calculator, I think I'm just going to table of values here, and although all the intervals are 0 to 1, so let's see, if I plug in 0, I get 0. If I plug in 1, I get 0. The plus or minus means whatever's happening between 0 and 1. There's a top half and a bottom half. And I think that's where this is going to get us, because if I just integrate the square root, I'm going to get the top half. So I think I need this this 2 on there to make sure I get the bottom half. So I want to integrate this thing, square root of x minus x squared, not that, from 0 to 1, and I want 2 of them, because if I don't include the 2, it's only the top half. The 2 will give me the bottom half. So man, that one's kind of tricky, especially if that's on the no calculator part. Although even with a calculator, it might be worse on a calculator, because a calculator you might just graph square root of x times 1 minus x. You'd see the top half, and well, they didn't even give that as an option, so I don't know. That's a weird one. 105 you can omit. We didn't do that, so you don't have to worry about that. All right, the back is some volume questions. Find the volume when the region is bounded by y equals x squared, x equals 2, y equals 0, rotated about the x-axis. So it's all about getting the picture right on these. So x squared and x equals 2. And y equals 0. So there's the base area. All those weeks on end of graphing parent functions in Algebra 2. Now is when it pays off, because you know what the graph of x squared looks like. You don't have to spend time plotting points, wasting time trying to figure out what a parabola looks like. Rotated around the x-axis. Okay, so disc or washer for this one? Disc, no holes in this one. So pi, the slices are dx, from 0 to 2, pi times big R squared, where big R is equal to that height, but what's that height? X squared. That height is a y height, which is x squared. I bet one of those wrong answers is if you don't square the r, but who knows. So x to the 4th, if I integrate that, I get x to the 5th over 5. From 0 to 2. Don't forget the pi, but all my answer choices had pi, so even if I'd forgotten it there, I think I would have remembered it when I got to the end. 2 to the 5th is 32, so there's my answer. That one was pretty straightforward. 107 rotated around the y-axis. So that's the other way. So I already know that's gonna be a little different here. It is the same. Pay attention. It's the same base area. So I can start with the same picture. There's my base. But if I rotate it around the y-axis, again, you're testing your artistic ability here. Alright, so integral. Disc or washers? Washers, there's a hole in there, so this is going to be big R squared minus little r squared. Dx or dy? How are my slices lined up? Dy, which means my limit needs to be y limits. So what are my limits? 0 to 4. They're stacked up in the y direction, 0 to 4. Alright, so next I need to figure out what big R is and what little r is. So big R is from the axis to the outer edge. What's big R equal to? 2. Good. It's a constant 2. It's 2 all the way down. The outside edge is a cylinder. So big R is 2. Little r is to the inside edge. Let's see. If it's measured from an axis, I don't have to worry about the minus thing. So that's just an x. It's an x distance, but I can't put x in a dy integral. So what does x equal? What is this? This is the curve that it's on. So if I solve that for x, I get the square root of y. So pi 0 to 4 minus y dy. So that actually turned into a relatively easy antiderivative. Like once you make it this far, it's easy. It was not easy to get it set up. So that'd be 4y minus y squared over 2 from 0 to 4. So 16 minus 8 minus a whole bunch of zeros. So 8 pi. Okay, so that was a tricky one because it was a washer. It was a tricky one because it was dy. But at least once you got over those hurdles, the actual integration wasn't too bad. Especially on the non-calculator part, if you're doing them right, there's going to be quite a few problems that are going to just kind of work out. You're like, oh, they kind of rigged that to my benefit. Provided I knew the calculus, it worked out okay. Let's jump down to 110. The volume of the solid is formed by rotating the region bounded by, let's see, y equals x squared and y equals 4. Y equals x squared and y equals 4. So we got this parabola again. But y equals 4 is the top piece. So there's my base area. And we're going to rotate that around -1. I think that would be a cool shape. I don't know if there's a name for that. It's the napkin holders, what some of you described it as.
Is it like
See if I can draw it better without the... Nope, that's it's not any better. So it's a cylinder. It's kind of it's an open. Man, I don't know how to describe that thing. The cross sections are a washer. It's sliced DX. Well, okay, so this isn't. If I can tell that it's sliced DX, I can throw out somebody. Which answer choice is tossed now? It's not A.
What B? Or is it a typo?
I wonder if that's a typo, because it's like, yeah, you're right. If there's not a DX at the end, that can't be it, unless that's a typo. Some of these go from -2 to 2, and some go from 0 to 2. But the 0 to 2 ones have a 2 in the front, so that makes sense. They're just doing half of it, half of the volume, and then doubling it. So I'm not worried about the 2s or the not 2s. That kind of makes sense. Right. I think it's -2 to 2, but I understand if you're going to go 0 to 2 and double it. So I'm good with all of that. All of that part is good on everybody. So now I need to find big R and little r. What's big R? What's the outside radius? Well, look at the outside radius. The outer edge is a constant. It's not changing. I've heard 4, I've heard 2, I've heard 5. Maybe if I had to put better numbers on here. I think it's 5 because we're rotating around -1. So it's 5 away from 4 to -1. Now the inside radius, that's going to be a little bit trickier. So it's x squared would be like the top part of it, but then I need to, like top minus bottom is the distance. The top is x squared, the bottom is -1, so it turns into x squared plus 1. Because it would be x squared down to the x-axis, but then there's an extra 1 because we've rotated it, or our axis is lower. So now which one of those is equal to that? I think I can throw out C and B don't look right. If I FOILed this thing out, I would get a minus x to the 4th. I would get minus 2x squared. And then 25 minus 1 is the 24. Okay, number 108.
It makes sense that it shouldn't have the little r squared, but also does.
So we'll set up 108. So it's the same base area. But it's on the x-axis, so that should make it a little easier than that one we just did. So disc or washers for 108? Well, not really. There's like one disc, right? It's all washers, and in the very middle there's no hole. But if it's only one spot, like that's fine. We don't have to write two separate intervals for that. So Borrowing from what they did, I think I'm going to go 0 to 2 and double it. That'll make plugging in a little bit easier. I won't have to worry about the plugging in a negative 2. Big R is 4, and little r is a y height, which is x squared. So little r is that the inside radius, which is the distance to this curve, and that curve is x squared. So 16 minus x to the 4th, 16x minus x to the 5th over 5, from 0 to 2. I'm betting one of these 5 denominators is right, but that doesn't really narrow it down a whole lot. So let's see, 2 pi times 32 minus 32 over 5. Minus 32 over 5. That's not fun. So a common denominator of 5 would be 160 over 5, I think. Minus 32 over 5 would be 128 over 5. But then there's a 2 out front, so 256 over 5. Ugh, yuck. All right. I've talked too much. I want you now, and you can work together. See how much of number 1 you can do on the free response. So I'll press pause. I'll give you 10 or 15 minutes, and this one is with calculator, which is good because these are ugly-looking functions. So grab a calculator. Probably put the first one in for y1 and the second one for y2. You could even label them that. That way you could use y1 and y2 the rest of the way. And then see how far you can go from there. And again, we'll come back in a little bit and go over that. So there's part 1. I found the intersection. And A was 1.0328 ... That way I don't have to, again, once you tell the grader that that's what A is, you can use A the rest of the way, because you've told them what A is, and they have to remember that the rest of the problem. You can also, I don't know if this is helpful or not, but if you're used to using y1 and y2, you can use that as long as you tell them what y1 and y2 are. So y1 is f of x, y2 is g of x, and now I can do everything in terms of a and y1 and y2. So the integral of g minus f plus the integral of f minus g with the appropriate limits, 2.04. Try part B, and I'll be back to do that one. So for part B, you're building squares, but just off of the S area. So cross-sectional areas is add up all of the squares. Area of a square is S squared. S is the top one minus the bottom one. That's the side length. And so it turns out that integral is pretty similar to the second part of the part A, but squared. So similar looking, but very different stuff going on here. Anybody else with 1.283? No units on this, so good with that. Good old part C. Always the last part is the way. A challenge. Let h be the vertical distance between the graphs of f and g in region S. So that's kind of what we were just working with. So h is f minus g, the top minus the bottom, like the vertical distance between f and g. Okay. Find the rate at which h changes with respect to x. Okay, it spelled all that out in words, but what's it asking for? The rate at which h changes with respect to x. Pardon? That's the derivative of h. It'd have been too easy to just say find dh dx or find h prime, so instead they used all the words to make sure you understood the sort of translation from English to calculus. So find dh dx when x is 1.8. So that would just be f prime at 1.8 minus g prime at 1.8. Several ways to make the calculator do that. You could go find them both and subtract them. But you could also, let's see, math, instead of math 9, math 8 is a derivative of y, make sure I get this right, y1 minus y2 not y1 minus y1, but y1 minus y2 at x equals 1.8. I just let the calculator do all of it. I don't have to write down anything other than the final answer. I feel like that one wasn't too bad of a free response question. Read carefully, because that, you have to be careful, but other than that, that's one where I would hope you would get parts A and B, and then maybe part C, maybe part of part C. Again, they're measuring your accuracy to 3 decimals. So if you find them separately, so like if you're looking at the graph and you find it this way, so dy dx of y1 at 1.8, and then you write that number down, that's fine, and then you do the same thing with dy dx for y2 at 1.8. Like, just make sure you write enough down so that you're accurate to 3 decimal places. Don't round till the end. But it would be easier, more accurate, to let the calculator do all of it. So math 9 is integrals, math 8 is derivatives. And another one where, like, if you know what you're doing, that problem shouldn't take 15 minutes. That's like 7 or 8 minutes maybe, if you understand what they're asking, and then that buys you some extra time for the harder ones when you get there. Let's skip down and do number 3. A little bit harder because we've got a volume of rotation rather than a cross-section volume. So let R be the region enclosed by that graph. This is a calculator problem, which is good because that's an ugly looking thing there. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. Okay, so volume. How much do I need to draw? Let's see. Starting to think out loud here. So there's my axis of revolution. I'm already seeing washers in my future. No, I'm not seeing washers in my future. I'm seeing discs in my. No, that's why I should shade my pictures so I know what I'm looking at.
We're all like, huh?
Wait. So yeah, it's not the inside vase thing; it's the outside napkin ring thing. But until I shaded it, I was definitely being misled. Trying to skip steps and it didn't work. Take the time to draw the picture, it helps you understand the problem. What's big R? Six. And a little r. Well, little r is going to be something plus 2. Right? Because this is y, or at least this top part is y. Be careful here. That part is y, but it goes down below that, so it's y plus 2. And rather than write all that out, I'm just going to say it's f of x plus 2. Leave it at that. So I'm almost ready to go to the calculator. I need the limits. So 0 to, how do I figure out where this last limit is? How do I figure out what this is? Somebody said it, I think. I need to find the intersection of my graph and y equals 4. So, x to the 4th, minus 2.3 x squared, nope, x cubed, plus 4, and y equals 4. And I have the same window as last time, and that's not enough of a window, so the y window is good, the x window is not good yet. See if we go all the way to 4, if that catches it. Oh yeah, that'll get it. So second calc, intersect, first curve, second curve, and then go get the intersection you want. 2.3. It turns out to be a nice one. That seems odd, but I'll take it. So I need to say that somewhere. F of x equals 4 at x equals 2.3. So I was getting ready to save that as a like we did the last time, so I wouldn't have this crazy numbers. But if it's only 2.3, then I think I'm just going to roll with 2.3 and not worry about it. So 0 to 2.3 of 6 squared minus y1 plus 2 squared. If I submit that as my answer, well, I need to find it yet. I might not get full credit. Do you know why?
Is there still calculus to be done?
There's still calculus to be done. So even after I get the answer, I still might not get full credit because. So let's get the answer and then I'll. Almost forgot the pi. 0 to 2.3. 6 squared minus vars y1 plus 2 squared dx. 98.868. This is still a little bit fishy. I think you'd probably be okay because you got the final answer right. But I'm using y1 and I haven't told the grader what y1 is. I haven't told the reader what y1 is. Now, he could probably figure it out, especially if you get the right answer. But I should probably note somewhere that y1 is f of x. Part B. Region R is the base of a solid. Of course it is. For this solid, each cross section perpendicular to the x-axis. So I know I'm going dx, and I've just got to add up all the areas from 0 to 2.3. Isosceles right triangle with a leg in R. Isosceles right triangle with a leg in R. What's isosceles mean? Two legs are the same. And so, especially if the leg is in R, that's good news. If I try to draw this. So what's the area of an isosceles right triangle? The area of an isosceles right triangle. 1/2 s squared. 1/2 base times height. So 1/2 s squared dx, where s is. What's s equal to? Four minus f of x. S is the length of this, so top minus bottom would be 4 minus the function, 4 minus f of x. I think I've labeled enough there to go give an answer and be good, but just for my own benefit, it's probably helpful to write this like I'm going to put it in the calculator. So that was a complicated question and picture to end up with a. Uh-oh. You're right. I had it right here. So that should be 4 minus y1 squared. Good catch. Oh, I almost forgot the 1/2. I guess I could have just divided by 2 later. But would I have remembered to do that? Who knows? But that's an example of if I had left off the 0.5, I probably would have gotten 2 of the 3 points for setting up everything right and then just punching it in wrong. 3.574. area. It feels like that area should be a lot less than that rotated area, just by looking, and it is. I don't know how much less it should be, but it's less. And then the always lovely last part of the problem. The vertical line x equals k divides R into two regions with equal areas. So there's my line K where those two areas are equal. Write, but do not solve, an equation involving integral expression whose solution gives the value of K. Well, they just told me that these two areas are equal. So I think I'll start with that. What's the expression for the red area? The integral from what to what? 0 to k. That's the big point. There's k of 4 minus f of x equals the blue area is the integral from k to 2.3 of 4 minus f of x dx. Write but do not solve an equation, so there's an equal sign, involving integral expressions. I got two integral expressions whose solution gives the value of k. Yeah, if I worked all that out, I could figure out what k is. So I'm done with that one. We had a problem kind of like that on a previous test. Some people set it up that way. A few people set it up where they said the integral from 0 to k is half the total area. So the integral from 0 to 2.3. So they would, either one of those would be, 4 minus f of x. So to me, area equals area, that's what made sense to me. But having given this problem earlier this year, or something close to it, a lot of you said that from 0 to k is half of the total area, and that makes sense as well. So either one of those answers would be okay. All right, so that leaves 2 free response questions for you to do on your own, and then however many multiple choice questions that we didn't get to. But you got a little bit of time left now, and I'll answer whatever tomorrow during class, and hopefully you'll be good to go before the weekend. Remember to keep spending time with the Stuff You Must Know Cold worksheet or formula sheet. At this point, you should be 5 or 10 minutes a night. Like, take one box of it or 2 boxes of it and review that each day, just to keep that stuff fresh in your head. Because we can review some every day, but we can't review everything every day. So you've got to kind of line out. I'm going to review box by box for a couple weeks before the test.